Alright, I want to create a cube, and I'm just going to flatten it out, and I just need a place to start working initially. This here is my camera, my main camera. We're going to use it, but for right now I'm going to take it, move it up, and rotate it, just so I can see what's going on. I'm going to change my pivot to global for right now. And just so we can see everything, let's create a directional light. And tell it to cast some shadows. Alright, so let's go ahead and create another 3D object. I'm going to create a sphere. Here in the inspector, I'm going to rename it to player just by typing in where the name is. So this has two things. It has a collider, which we need, but I also need to attach a rigid body to this sphere because we're going to use rigid body physics to move it. So I'm going to go to Component, Physics, Rigid Body. By default, use gravity is clicked, is checked on, which we want. So, and now let's change the color of our sphere so that we can just see everything a little bit better. So I'm going to create a new folder in my assets folder. Let's just name this materials. I'm going to double click inside that to go in that folder. And we're going to just create a new material. And we're going to name it player. If I need to rename our asset inside of here, I can click on F2, click it, and then hit the F2 key, and that'll allow me to rename it. And then these are your standard assets. And I'm just going to turn this to red for right now. And to apply this to the player, I can go into its mesh renderer, materials, and select it, or I can just drag it onto the player. Alright, now let's create a folder for our scripts. And I'm going to go to create C# script. And two things. When you first create your script, you have to give it a name. That name is the name of the class as well too. And they cannot be different. So I'm going to name this player movement. Once I name this, this is the name of the class. And for the name of the script of the file, it has to be the same name as the class. That's just how it works in Unity. And if I change one, it's not going to work. I'm going to get errors unless I change both of them. Now to start off with, I'm going to use model development. I think Visual Studio's already checked by default. I'm going to go to Edit, Preferences, External Tools, and click on Model Development. Now to open it, close that, I can double click on my script and it will open it in model development by default, automatically. No, it doesn't. It has to be the same name as the class. So I'm going to show you where the class is once this opens up. All right. So you see here, this is the name of the file. The file name also has to be the name of the class, and this is the class name here. And not class as in GM402, but an object is a class. Now, two things. This is your opening curly brace for the class. This is your closing curly brace for the class. Anything that you're going to type as in it has to be calculated goes within those two things, and then those go within methods and functions beside those. So now there are instances where I have to tell it to use a certain like Unity engine.ui or other things, and that will go here. That's part of template, but that's not calculated per frame. But things that actually will be eventually calculated per frame don't go, have to remain inside of the class.
Are you doing a video capturing?
Yes.
Okay.
And hopefully it doesn't fail. Now, we have a couple of, now there are some variables that are not put up there that will be unique to Unity. But for right now, let's get it moving. So we're going to create a float, and we're going to name it speed. I want to say that's equal to 10 for right now. Then I'm going to create a vector 3. Vector 3 is X, Y, and Z, and it's how you can move. One of the ways you can move within, well, it's pretty much the way you move within space, or denote a direction in space, or a position in space as well too. So what we're going to do, vector 3, direction, and we're going to leave that empty. And this is X, Y, and Z directions, where I want to move in X, Y, or Z. There's also a vector 2, which would be X and Y, and there's a vector 4, which is X, Y, Z, and alpha. And I think I'm going to start with that. Okay. So first off, what we're going to do, yeah, we can add that later. Let's just get basic movement. So what we're going to do is this. We're going to tell direction to be equal to a new vector 3, and that vector 3 is going to be I'm going to make this bigger, our up and down, our arrow keys. So I'm going to do input dot get axis and I want it to be horizontal. This will be our left and right arrow keys. For Y, 0, and then for Z, it'll be, we're going to use input dot get axis our vertical, which would be X, our up and down arrow keys. So essentially, we're using the arrow keys to tell the where to go, and we're mapping that mapping that information to our direction. All right, now what we have to do to actually get the rigid body dynamics is we're going to have to do, let's go do the long way first, and then I'll shorten up over to as time. So this game object, get component, we're going to get our rigid body, and when I'm saying get component, that is a component, this component is here. We're accessing this. That's attached to our player. And what we're going to do is add force. And add force, we're going to use direction. And then we have to use a force mode. And then this is telling us what we may need for our methods and functions. So force mode, and I'm going to use force. Now, let me do this. Update, and some of you got this read on the pre-quiz. Oh, it already has it there. Duh. It is going to go through all this line of code once per frame. What we're doing here, we are grabbing our rigid body component and using its add force to help the ball. Now, for me to actually build it, I can't just save it. I have to click on build. You can hit F8 or build. And if you have multiple scripts, you can tell, well, in this case, I'm doing build all and rebuild, but I just always hit F8 build all. Now, at this point, the script is not attached to player. There's two ways we can do this. We can go to have the player selected, component, and now that we have scripts and player movement, or I can drag this in the hierarchy on top of the player, or I can drag it and go into my actual scene view and drag it on top of the player. Now that script is in its inspector, it's part of it, it's a component. And to test it, we'll hit build. And if I hit my back, I'm hitting my back arrow key, it moves. If I hit my left, it moves. I hit my right, it moves. And it falls off. So, now what I'm going to do is we're going to add, oh, no problem. I'm going to add a little bit more to this. So we have this here, but we really don't have speed per se. We're just using, we hit the arrow key, it adds force, and it's going to increase incrementally over time. But we're going to add a little bit more to this. So for this speed, I'm going to create a new float. Now, here I declare my float for speed here, but I can also declare a variable inside of a function. This right here is a function. Now, I can't just create a variable outside of my class, but if I want my variable to be accessible to all my functions or everything I create in my script, then I have to do it at the top. Or if I just need it accessible for items within inside of my function, I can do it here. But we're going to create a float in here. We're going to name this amount to move, and this is going to be equal to speed times time dot delta time. Now, time dot delta time is the time since the last frame. And there's different types of time, but in this case we're using delta time. And what I'm going to do is this. So I'm actually going to copy some of this and grab another component. So add force. Let's get rid of add force. What I want now is it's not drag, and for some reason now I'm just drawing a big old blank. It is. Yes.
So you said delta time. How does that work?
What Unity is doing is to calculate time. Like you have different types of time. Like you have time.time, which is time since the game started.
Okay.
But delta time is using the time in between each frame and builds up, so you can use that for speed and certain things. And depending upon what I'm doing, I might want to use delta time. I might want to use time. There's another one I'm drawing a blank right about now that we could use as well too. I want velocity. I just remembered. And I want that to be equal to direction times amount to move. I may not be able to do that, so I might have to make a quick adjustment. All right. So it's a little bit slower now. So we're going to ramp up the speed a lot. And I'm going to rebuild it. Now the problem here is now it's falling slower because of my velocity. And what that means is velocity is, how fast you're going in a particular direction. But since this is 0, this can cause some problems. Now, I can make a decision and say, well, I might want to switch the order of my code, or I can always have this at a negative direction so it does that. So let's do this for right now. And we're going to put in negative amount to move for y. And it falls a lot faster. Now here, if I don't want to put in a larger number, I can always multiply that by something. But for right now, let me ramp that up to 5. Now granted, depending upon your scale, it may be too fast, or it may be just right. I've ran that sometimes with different people. There we go. And that might be a little bit too fast, so I've been out of 200. And I'm building, and I'm going from there. So here we're adding, we are using amount to move to give our velocity a negative direction, since we're using it. Alright, the last thing that I want to do, because we're running out of time, is I am going to, uh, if we fall off, if we get hit, we're going to set a start position for our object, and then if it dies, we're going to use that as a spawn point. So what I'm going to do is create a new vector 3. I'm going to name that start position. And then in start, say start position is going to be equal to transform dot position. So we already know this denotes a position in space or a direction in space. So what we're doing is telling this. Now, two things. All of these are private. You have private and public variables. Private means that that variable is only accessible within that class. Public means anything can access that variable. So if it's public, it will be denoted like this: public float, public vector 3. And you will see it, if I made my speed public, in my inspector, or well, and there's one instance where that doesn't happen, that's if it's static, and we'll talk about static variables later. You can see it here, and I can change it inside the inspector, or another script can change it as well too. I don't really need this, I'm just using it to demonstrate private. Now if I don't denote it as public, it's automatically private, or I can also type it in as being private, and it was also private as well too. So if it's not public, it's automatically private, or you can denote it to be private. Now, since we don't have any traps yet, and we're just getting some of our basic movement set up, what I'm going to do is figure out how far I want this to fall before I tell it to respawn. And so right now, we're at what, 57, so if I say, let's say negative 20, that should allow it to respawn in this position. So this is what we're going to do. So we're going to create a conditional statement. And we're going to use an if statement. So if transform dot position, and every time I'm using transform dot position, I'm using that transform dot position of the object that this script is attached to. And then we can't do just transform position because that's X, Y, and Z, but I need to get a particular position, which is Y. So I'm gonna hit dot Y, and then it's less than or equal to, let's say, negative 10. Then we're gonna say transform dot position is equal to start position. I'm just going to copy and paste. Now, and let's close this with the open and closing curly brace as well too. Now, what we're doing in start, I'm setting all those variables for start position. So this is going to give me the X, Y, and Z position of my object when we start, and this only happens when the object is initialized. And then here, So right now, that start position is now set to where the player currently is. That information is in there. If I roll off, we go back. And so we can respawn the player. Alright, now